In our last lesson, we're going to take a look at scatter plots and lines of best fit, as well as talking about the correlation between data sets. So a scatter plot shows two data values on the same graph. So for example, you might plot height versus age. Age would go on the x-axis, and then you'd be able to see the relationship. Obviously, the older you are, the taller you get up to a certain point. Correlation is the strength of the relationship between the two variables. So if you looked at height versus age from birth through 16, it would be a very strong correlation. The older you are, the taller you are. But as you grow into adulthood, the correlation would be a little bit less strong. The example of height versus age or height versus weight could also be an example of positive correlation. They both increase together. Negative correlation is when one variable increases and the other decreases. So for example, the hotter it gets outside, the lower your heating bill is. So that would be an example of negative correlation. And we'll also take a look at how to find what's called the correlation coefficient. This is a number between -1 and 1 that describes the strength of the relationship. So the closer the correlation coefficient is to -1 or +1, the stronger the correlation. So a correlation coefficient of -1 would mean a perfectly linear negative correlation. A correlation coefficient of +1 would be a perfectly linear positive correlation. And a correlation coefficient of 0 would mean there is absolutely no correlation at all. And finally, we'll take a look at how to use our graphing calculators to find what's called the line of best fit. What you could do on a data set is sketch a line that seems to go through the data fairly well, and that would be a line of fit. But your calculator can calculate the line of best fit. It's a line that goes perfectly through the center of the data, and we can use that to make predictions. First example is creating a scatter plot by hand. I decided not to do that in the video. One, it would be quite time consuming, and two, I really hope you all know how to plot ordered pairs on a graph. So here is the table of the data values, months owned for the exercise machine, and how many hours you exercise. So as you can see, when you first get your exercise machine, you tend to exercise quite a bit, and then the longer you own it, the less you exercise. It gets a little old. So we can see on the graph this negative correlation or the negative relationship between these two variables. So I would just say a negative correlation. We can also estimate the strength of the relationship by putting a line on the data. So if we look, a line seems to go through the data right there. And you can see several of the data values are kind of a little bit of a distance from the line. So this looks to me like a moderate negative correlation or moderately strong. It's not a real strong correlation because they don't fit the line really well, but there's definitely a relationship between the two. Next, we're going to take a look at using our graphing calculator to create a scatter plot, as well as find that line of best fit. So I've got my calculator here, and I already typed in the data, again, to save time. As a reminder of how you type in the data, if you've got yours, you go into Stat, it's this button right below the Delete button towards the top, Edit, and then the X values go in list 1, and your Y values will go in list 2. Remember, if you've got data and you want to clear it out, you go up to the list. Once the list is highlighted, you can hit clear and enter, and it'll clear out that data so you can enter in a new data set. So again, I entered my data. I've got all of our humerus lengths in my X values and the height in my Y values. So to graph a scatter plot on your calculator, there's two options. You can go into the Y equals and just hit up until the plot is highlighted, or you can do the second Y equals and it takes you right to stat plot. Then I'm going to hit enter. I want to turn my plot on, so I'm going to hit enter again. Type, we want a scatter plot, so we're going to leave it as the dots. Notice we could do a line graph, a histogram, a box and whisker plot showing outliers, or a regular box and whisker plot. Not sure what that last one represents. All right, so under here, this shows we want our X values to be list 1 and our Y values to be list 2. That will be our default, and that's the easiest way to get your data entered. And you can choose the different marks if you want open box, if you want a plus sign, or a dot. Next, you'll go into this middle one. This is called zoom. And if you scroll down, you can also just hit number 9. 9 is stat plot, but if you scroll down to number 9, it says zoom stat. That is to automatically fit your data to the window so you don't have to try and figure out the best window to view it. So we're going to hit enter, and then it takes us right to the graph, and there's our scatter plot. Those are all of the points, those data values that we entered in. Next, we're going to write that equation for the line of best fit. So we're going to go back to stat. This time we're going to go over to calculate, and we want the linear regression. Number 4, linear regression is the technical term for line of best fit. So you can just hit the number 4, and it automatically comes up. There was one other thing I forgot to tell you. So when you hit enter here, if you don't see everything that's on my calculator, we'll have to turn the diagnostic on. So here we've got our a value, that's our slope. So when you look at this equation, we've got y equals ax plus b. So a is our slope. B is our y-intercept, and then down here, R is our correlation coefficient. If you're not seeing R squared in R, real quickly we'll run through how to get that. So you'll hit second, 0, and that takes you to the catalog. And notice how we are not in regular text, we're in the alpha text, which means when we type something, it's going to come up with the letter. So right here, when you're looking at the green, that's the letter D. We want to turn our diagnostic on, so we want to scroll to the D's real quickly. And then scroll down until you get to diagnostic on. Once you have diagnostic on highlighted, simply hit enter. I'm not going to do that because I have mine on, but you'll hit enter twice. You'll hit enter, enter, and it will say done. And then you'll have to go back into stat and recalculate that line of best fit. So here we've got our data on screen again. So I'm going to write that equation for the line of best fit. And we had y equals, and I'm okay if you round to the nearest 10th or 100th on this one because it is kind of putsy to use that equation with so many decimal places. I did, however, round to the nearest 1,000th for my slope, but the y-intercept was so close to 72, I went ahead and rounded to the nearest whole number. So there's our line of best fit. Next, we're going to use it to predict the height of a woman with a 32 centimeter humerus. So when we look at our table, the humerus was our x value, so we're going to substitute that in for x and solve for y. And I rounded to the nearest whole number because all of the data values in the table were rounded to the nearest whole number, so I got about 160 centimeter height for this woman. And the last piece is what is our correlation coefficient. So on our graphing calculator, our correlation coefficient was that last one, that R value, 0.991. And what does this say about the strength of our prediction? 0.991 is extremely close to 1. Remember, 1 was perfectly linear correlation. And ours is a very strong correlation. If we look at that scatter plot again, you can see if we were to put a line through that data, nearly every data value would touch the line, and those that weren't touching the line would be really close. So what this says is that our prediction is accurate. I would guess, this is just making up a number, but I would guess it's accurate within 1 centimeter because of how strong our correlation is. All right, and on the next 2 slides, if you forget or if you want to reference, I've got how to get that scatter plot on as well as how to create that line of best fit and get your diagnostic on. If you've got a graphing calculator, go ahead and try this. If not, we'll run through it together as our warm-up tomorrow.